Engineering 305, Chapter 6, Section 5, Stresses on Oblique Planes. This is an interesting one. There are no new learning objectives associated with this section. There likewise are no new equations from the study guide. The point of this section is to say, look, if I have, and I got to make sure I pick a color, if I have a cylinder and I put an end on it like that, so you know it's a cylinder, and I put a torque on that side that way and a torque on that way, then I know that I get this little stress cube, and this side wants to go up, and this side wants to go down. And if we amplify that and blow it up, and we did the analysis, and you know there has to be these going on. That's my shear stresses. Those are necessary to keep it from rotating. If I have that, then I have sigma x is equal to 0, sigma y is equal to 0, and I have a shear stress equal to, well, we have the equation, it's this TC over J. Now, when we're talking about oblique planes, what we're doing is we're going back to chapter 2 or to chapter 3. 3 was strains, but 2 was stresses, and we're going through stress and strain transformations. And we're starting with this as our starting point. Now, we have to ask, well, what's theta? Well, you know, isn't it more interesting to say, well, for any theta, we could do it for any theta. Well, if you're going to do it for any theta, then all we're looking at is Moore's circle, right? That's all we're looking at is Moore's circle. So if we're looking at Moore's circle, we're looking at a situation like this. There's my circle. My axis passes directly through it because that was the erase button. Because the center of my circle is at 0. This is my x-axis. This is my y-axis. There is no tension or compression. There is no sigma x and sigma y are 0. So I'm going up and I'm going down. That's it. And if I want to know what my principal stresses are, I need to rotate, get a different color. I need to rotate to this axis because this point here is going to be sigma P1 and this point here is going to be sigma P2. I should have labeled this also. That is my tau max, and that's the radius of the circle. Well, if I'm rotating like that, that's 90 degrees here. Sorry, I can't see that. It's 90 degrees here. So that theta max is going to be equal to 45 degrees. That's the stuff we've been doing, right? That's the stuff we've been doing. We do get 2 equations out of this section, but they're not. They're derived from the stress transformation equation. So I don't know that we need them. They look like that, right? And that was that alpha is related to, it's the double angle theory. And it's not worth it. You can look in the book. This is just not worth it. I think the reason we do this section is because it creates a great example in class of this hose collapse, and we will do that probably on Wednesday, just because we're skipping Tuesday when this material is. But that's a great reason to do it. You can visually see how this hose is collapsing, and that's because we're getting the compressive stresses, and then it collapses, and it's kind of a buckling failure. There's more going on than we're actually admitting, but it's a great demo. We also see in the textbook some great pictures of these torsional failures. They look like those. So you can see the wrinkling. I think the best image is in picture B. You can see the wrinkling and the buckling, and what's left behind is at that 45-degree angle. You're seeing that very clearly in C as well. What you might be seeing in A is actually some stretching, because when they twisted that part, they didn't let it shrink to take up the fact that when you twist it, it should shrink in length. It's a Poisson's ratio thing if you think about it hard enough. Um, and they're claiming the same thing if you read the text on image D. The reason they've got those spirals there at a 45 is because they weren't allowing it. There was some tensile stress because they weren't allowing it to shrink in as they loaded it. I would say we would do an example problem, but I do not have plans for any. It is just a stress transformation equation. So I think we're pretty good. My next presentation is going to be the FEA on a scuba tank. That's for Wednesday's class. Hope you're doing well. Don't worry, there'll be more. Wrong button.